To the webinar, Quality Assurance, Quality Control in Action, Strengthening Data Integrity from a Laboratory Quality Perspective, brought to you by CIM Magazine and Saskatchewan Research Council. I am your organizer, Michelle Beacom, Managing Editor of CIM Magazine, and my co-organizer is Ryan Bergen, Editor-in-Chief of CIM Magazine. Just a little housekeeping before we get started. To ensure that you have optimal audio, make sure that if you are using the computer audio, you've selected the computer audio button. And if you joined by phone, make sure you've selected the phone button. If you have any questions during the question period, please type them into the question box. You'll find that under the question mark, and you can type in your questions right here. And the questions will be held until the Q&A period after the presentation. Now I will turn the webinar over to Ryan to introduce today's presenters. Thank you.
Hey, great. Thank you, Michelle. And just a note on the questions, it's really helpful if you just give them a quick proofread before you hit send, so they're as clear as possible. Good. All right. So thank you so much, Michelle, and thank you to everyone for joining us today. Today's presenter is Danielle Weichel, who is Quality Supervisor at SRC Geoanalytical Laboratories. She previously served as an industrial associate scientist and as a health safety and environment technician at Canadian Light Source. In addition to her work experience, she has 10 years of experience in environmental geochemistry and has a master's degree in geology. And then Danielle will be joined for the question period by Roxanne Ortman, manager of SRC Environmental Analytical Laboratories. So with that, over to you, Danielle.
Thanks so much. So as I said, getting right into it, today I'm going to talk about quality assurance and quality control in action and how we strengthen data integrity from the laboratory perspective. So the first thing we're going to do is a land acknowledgement. So greetings and acknowledgement as we are on Treaty 6 territory in the homeland of the Métis, where SRC's headquarters are located. We pay our respects to the First Nations, Inuit, and Métis ancestors of this land and reaffirm our relationship with one another. We understand the importance of acknowledging the past and embracing a future where Indigenous peoples and their traditions are valued and supported. Together, we strive for a more inclusive and equitable business environment that benefits all. So that was a great introduction, but just a little bit of background on myself before I get into it. I have my bachelor's in chemistry from the University of Saskatchewan, and as was said, a master's in geology, and that was focused on geochemical controls of contaminants in a low-level radioactive waste management area in Ontario. As was said, I was formerly an employee at the Canadian Light Source, where I was on the industry services team, and now I'm with the Geoanalytical Laboratories as the quality supervisor at SRC. Today, we'll start with a brief introduction of SRC, and I'll talk about the labs that use our quality system and the framework that I'll be discussing throughout the presentation. We'll move into why quality matters, and really this is the biggest part of how we get people on board with quality. We need to convince them that it is as important as it is. And then the quality system components, we'll talk about everything that goes into our quality system to make a really robust framework, the data integrity piece, and then continuous improvement, which really is the backbone of everything. We'll move into getting buy-in and how we make sure that we're continually having quality as top of our mind for everyone within the laboratory and also the corporation. And then we'll talk about some key takeaways, and you'll have an opportunity to ask questions. The area that I do quality in at SRC is the Geoanalytical Laboratories and also sorting and separation. The Geoanalytical Laboratories are ISO 17025:2017 accredited, as well as CNSC licensed. We provide geoanalytical testing, automated mineralogy, and we serve the mining and mineral exploration industry. We've been around for about 70 years in analytical methods, and interesting fact that's kind of fun, our senior scientist who was part of our lab for 53 years, just retired 2 weeks ago. So that's pretty cool. And we have analytical packages available for all of the commodities that are listed here. And of course, we work together with our clients in industry to do method development for anything that's emerging in the industry. So sorting and separation offers customizable pre-concentration testing and piloting services. They focus on sensor-based sorting, crushing and sizing, heavy liquid separation, magnetic separation, and dense media separation. And they operate the world's largest commercial diamond laboratory. And that's the portion of the laboratory that is currently 17025-2017 accredited. And we do both macro and micro diamond recovery and specialized services. Additionally, they do heavy mineral processing and indicator mineral recovery and analysis. And the last lab that we'll talk about today is our environmental analytical laboratories, which, as was mentioned in the introduction, Roxanne Ortman, who's here with me for the question and answer period, is the manager of. It's one of Canada's most complete suites of analytical services in one single facility. They are also ISO 17025-2017 accredited, and they're accredited by CALA, whereas the Geoanalytical Laboratory is accredited by SCC, or the Standards Council of Canada. And EAL is also licensed by CNSC, so they handle radioactive samples as well. And their services include testing water, soils, vegetation, and biota for the list that is there. And this also includes petroleum analytical testing for biofuels and transformer oils. Okay, let's get right into things. The first thing we're going to talk about is why quality matters. So the thing about quality is it's the way that you ensure that your data is accurate and reliable. If you have a really robust framework set up that focuses not only on your data, but every piece of the data and how it's analyzed and corrected and then sent out as well and reported, you're going to prevent a lot of errors and incorrect results. And this is going to allow trust to be built with clients, regulators, and stakeholders. Having a good quality system also supports regulatory compliance. Of course, I said we're accredited in 17025-2017 and licensed by CNSC, so it makes sure that we're following those standards to the best of our ability. And then it also allows us to collaborate with the people that are accrediting us with those when they come for audits. It makes sure that we can continually improve our system. It also facilitates audit readiness and traceability, so that we know when something does go wrong, we can trace back and figure out the root cause of anything that's happened. It drives operational efficiency, so this reduces manual errors and rework, and with something, especially something like an EQMS, which SRC is fortunate enough to have just implemented, it enables us to automate these workflows so that they're streamlined and we're not spending any manual time doing these processes. And then additionally, as I said in the intro, it promotes continuous improvement. And this is super important. It encourages data-driven decisions and corrective actions, and it allows us to collaborate, and it enhances our training. And lastly, protecting environmental and public health. So it supports sustainable practices in mining, agriculture, and municipal services. A lot of times when I start talking about quality with people, and actually even in within our own council, you start to talk about quality with your colleagues, the first thing they think about is document management. And a lot of people believe that quality is document management. So you think about your SOPs, your forms, your laboratory information bulletins, and you have a document management system set up, and they believe that is quality. But there is so much more to quality, and that is a huge piece of it. But that's sort of how we organize it, I suppose. So this just shows us the other pieces. So things like supplier and client management. So ensuring that in your quality management system, you review those suppliers on a regular basis and make sure that they're providing exactly what you need them to. And then client management, making sure that you have all the notes you need for your clients so that you can fulfill what you've set out to do for them to get them the best data you can. Another component is change controls. So if you have something that does need to be changed or a deviation, how are you making sure that that rolls out seamlessly and that you're tracing anything that is being changed and determining what the impact might be before you even implement that? Something that people usually don't realize as part of a quality management system is training management. And it's actually a super important piece, because by having training management in your quality management system, you can show that you have proficient people for every task, and you can also figure out where cross-training can help. So if you get busier in one area of the lab, you know who can go where, and you're going to have a seamless transition for that. Quality event management. So this is things like doing internal audits, how is that tracked? Things like non-conformances, and we'll talk about all of those things as well. And then the other piece, and one of the biggest pieces, is risk and audit management. And risk is sort of the building block of quality. You need to figure out how something is going to impact things, and then that rolls into your continuous improvement. So turning that risk into a way to find an efficiency or a way to improve is huge for your quality system. And lastly, the QC data checks and standards, which is a huge part of having data integrity within the lab. But without the rest of these pieces working together seamlessly, you're going to struggle with that. Okay. So today we'll focus on two parts of data integrity. We're going to start with, how do we keep things going right? So what tools are we using to make sure that we're getting the best data every time reliably? And then inevitably, we know things are going to go wrong. So what are we going to do when things go wrong to ensure that we can get back on track and get back to how do we keep things going right? So starting with how we're going to keep things going right, I call this a quality toolkit. That's what I'm going to refer to it as. We use these tools as a way to check on our performance. So if you have a good quality system for your data, you're going to have a constant feedback loop. And that's really key. You want to have feedback coming in on every piece of data that you're receiving. So we use things like proficiency testing, standards, QC charts, blanks, sample split repeats, reagent blanks, internal audits, and external audits. And we're going to dive into what each of these is and what they do for us in our quality system. So the first thing we're going to talk about is proficiency testing programs, or PTPs. These are structured assessments that compare a lab's results against predefined standards and or peer results to evaluate performance. So generally the workflow of a PTP is they're an accredited body that provides the PTPs will send you samples. You'll bring them in and analyze them exactly how you would analyze a normal client sample. Then you send the feedback or the data back to the provider, and they do a full statistical analysis and create a report and send that back to you. So for ISO 17025:2017, under the accreditation with SCC, we need to do 2 of these in every method passing per year. If you have a fail, you have to figure out what has gone wrong, and we're going to dig into that a little bit later in the talk. And the best part about this is it's external feedback. So we can do a lot of things internally that give us feedback, but a really key point in your quality system and making sure it's robust is having external feedback as well. Why do PTPs matter? They validate our testing capabilities and regulatory compliance. They enhance our quality assurance and result accuracy. And they identify areas for improvement and foster continuous development. So it's okay if you fail a PTP, but it allows you to figure out what's happening and why you're not passing it from an external standpoint where you're being evaluated against peers. And then key benefits, performance benchmarking, reliable feedback loops, and evidence of effective quality controls. So it's also a way to have continuous improvement within your quality controls and revisit those every time you get that feedback. Moving into standards and quality control samples. So the standards that we use at SRC are standards that are certified reference materials, or CRMs, and these are highly characterized substances used to validate analytical methods, calibrate instruments, and ensure quality control in laboratory testing. they come from with a certificate of analysis that provides the exact composition and uncertainty values. So they come with limits. So we'll talk about limits in a little bit, but they tell you exactly what to expect from that sample every time with specific methods. Really important things for putting quality control samples in place and standards is strategic placement. So your QC samples are placed at regular intervals to monitor the response and stability of the analytical process over time. So as a lab, as you're doing your method development, you need to determine what that regular interval needs to be and what it needs to look like for every different method that you do. Then you can do limit tracking and limbs. So this is system-defined limits, and this helps flag any deviations and ensure consistent performance. So we're going to dig into this when we go into those QC charts in our certificate of analysis, but it allows you to see if you're falling within what you're expecting to receive from a certified reference material. And standard checks, these at SRC, these allow us to automatically highlight potential issues or anomalies within our process. And at SRC, we're tracking the process from the very start to the end. And we'll talk about how we do that as well. QC charts. This is to visualize performance trends and detect shifts and drifts over time. And these are really important because they give us a full picture of how things are going as we continue through time. And you can sort of change your time frame, and we'll look at that as well. The other really important thing about standards and quality control samples is that if you're working with your clients collaboratively often, they should be sending in their own standards that are blind to us. So within their samples, they'll have standards that they have received from a provider, and they'll put those in blindly to us. We won't know they aren't samples, but then they can also track our performance, and that provides another external feedback loop for the lab. Okay. So I was talking about a certificate of analysis. If you email me and ask me for the standard limits for any standard, this is what you'll receive back. So this is our standard DCB 01. The package that it's for is ICP Total MS. So you get your standard, your package, it'll say the date that I retrieved it from, and then your analyte name. So all of the analytes are listed on one side here. The value is the mean. So this is what we're expecting as our mean value. We're hoping to have values near that. And the range, this is the lower and upper limits. So at SRC, our lower and upper limits, as is best practice, are 3 standard deviations above and below your mean value. And when you're putting a standard into use, when you're introducing a new standard, there should be a system for doing that, a process that's followed every time. And that allows you to determine those limits for every package that you're putting it in for. Okay, control charts. So this is the next tool in our toolkit that we're going to use to ensure that things continue to go right. So this is maybe a little bit hard to read, but I'm going to go through and explain it to you. Your x-axis here is the number of runs. So in this specific example, I have 0 to 100 runs, and that's our most recent 100 runs. But in my limb system, I can determine if I want to use most recent, or I can use a date range. So if you are seeing something that's a little bit interesting in your standard behavior, you can zero in on exactly what's happening by choosing your date range. Or for me, when I'm doing our yearly management review, I need to do a year of data to analyze exactly how things have been performing in the lab. So I would put that in, and then it would plot it here. I also have on this y-axis, this is our value. So this is the value that's returned when we're running the standard. The standard's up here, and then the method. So for this one, it is BL5U308. The green line here is the mean. So that is our average value. That's the value we want to return, ideally very close to. And 3 standard deviations above, that's our limit. And 3 standard deviations below, that's our limit. So those red lines are the limits. If we have any point above or below the limits, we need to know why. Why are we having an outlier? So At that point, we would send this to a scientist, and in our LIMS system, if you hover over a data point, you would find out what group it's from and also the sample ID. So that would help you to identify the data point that was anomalous. And then you would send that to the scientist. The scientist goes through and tries to figure out what's going on. We do a root cause analysis and determine what happened there. Ideally, you're seeing your points oscillate around the mean. So you want a statistical randomness around the mean. We have an additional set of limits that we call the warning limits, and those are 2 standard deviations above and 2 standard deviations below the mean. So they're not shown on here, but generally they're shown as a yellow line. And if you have 3 points above or below the warning limit consecutively, we would call that a bias warning. So if you get 3 points consecutively above the mean, above the warning limit or below, you're going to get a bias warning, and that will also have to be investigated to determine why your standard is acting bias high or bias low. And then the last thing that you want to look for is a trend. So if you're having several points, in our case, we do 10 points trending upward or downward, you're starting to see a trend or a variance or a lack of statistical randomness in your standard behavior. So you would also need to figure out what's going on there. So control chart is a very simple visual way to see the performance of your standards. The next tool that we have in our toolkit for how to keep things going right is a QC check. So this is what our QC checks look like, and they have been on every group, on every analysis. This is the group here. You have the sample, you have the analyte name. This is your mean value here. I don't know if you can see my cursor. I'm just kind of hoping you can. And then you have your min and max value, which is your limits. And then it will give you a reason. So for this one in particular, you were hoping to get around 2.28, but between 2.14 and 2.43. And then the reason that this is coming up and highlighted is we were below the limit, and it tells us the result. And this allows the scientists to dig in further and go back and look at the data, determine if there is a real issue here, if it was an issue with calibration or if there's a correction factor. It allows them to determine what the root cause was, and then they might ask for the group to be rerun, or they might find the reason. Maybe there's an interference in the spectra. It gives so much information for the scientists to start with. Additionally, in our standard checks, which is equally important, is it tells you when a package was good. So you know that this package was checked, it was good, and 45 results were checked. So you will know based on your data what you're expecting to have checked, and you can go through and ensure that every part of that was checked. And just a quick note here that all of our groups are checked by scientists and signed off prior to data release. So the next tool in our How to Keep Things Going Right toolkit is blank samples. And these help us to ensure accurate analyte concentrations by identifying any signal that is not related to the analyte. So really in a blank, you should have very little happening. So if we're seeing something, we want to identify what's going on there. The blank that we use is a method blank. That's what Geoanalytical calls it. I'm not sure if EAL has a different name, but we use Quintus Quartz, and it's a full process blank. So what happens is the client samples come in, and at the same time as those samples are prepared, we put in a blank sample. And this is going to detect contamination throughout our entire workflow. And something that is very unique to Geoanalytical Laboratories and also very useful as the quality supervisor is our samples go through their own sample streams. So different types of samples get weighed on the same balance. They get weighed the same as their same type of samples. So they all go through the same sample stream, they go through the digestion, and then they go to instruments that are specific for that method. And that really allows us to track back. If something goes wrong, we know exactly what groups could have been affected and where the problem happened. So this method blank is very important for the entire process. Additionally, we use a reagent blank, and this allows us to see what's happening once we start digestion. So basically you have an extra tube and you're putting every reagent that's put into the tubes with the sample, but you don't have any sample in it. So it's used to check for contamination that would have been introduced by instrumentation or reagents. And then that allows you to know if you've seen nothing in your method blank, but all of a sudden you're seeing something in your reagent blank, it really helps you find that root cause quickly, which is very helpful for me. And then the last thing I want to mention on blanks is clients should send blanks as well. So you ideally would like your client to send blanks as blind samples for us, meaning they send it the exact same way as they send the rest of their samples, but they know that it's a blank. So when they get their data back and they put it into their own database, if they're seeing any contamination or anything showing up in their blank that's unexpected, they can alert us and then we can check that data. And I keep coming back to that really the relationship between the client and your quality supervisor is super important to ensure that you're having that data integrity, because if they have their own quality system in place, we have ours in place, we have double the chance of getting anything that might be happening not exactly how we want it to. The next tool that we use is an SSR, or replicate analysis. So an SSR is a sample split repeat, and what this means is during sample preparation, we split our sample into two, essentially. So when they're doing the crush and split process, they split them, and then this allows us to assess the homogeneity of the sample. It ensures that we have consistent distribution of the analyte across subsamples. So if you have your sample split and those aren't matching within a certain error, you know that the crush was not successful. And if your crush isn't successful, you're not getting a representative sample of the rest of your core in the geoanalytical case, which means you would want to redo that because you want to make sure that you have a representative sample of that core to make sure you know exactly what analytes you have at what concentration. So the SSR is super important to have. And then we also do a repeat or replicate analysis, and this involves reanalyzing one sample from a batch to evaluate the precision of the analytical process. So you kind of want to randomize this. Here it says it can be placed adjacent to the original or randomly within the batch, and that's important. You want to change it each time. You don't want to have the process so strict that you're doing the exact same way every time with this one. You want to have it, having it adjacent or not can help you see different variability. And as it says here, it helps detect variability and confirm the method reliability. And again, with this tool, you want your clients to be sending duplicate samples as well that you don't know about. So you want them to send duplicate samples that are numbered the same way as all the other samples, but they know in their database which one is a duplicate. And then you can also detect any errors in the data there to ensure that that data integrity is there. Okay, so we've talked about all of our tools and how we're going to keep things going right, but inevitably we are going to have things go wrong. So every time things go wrong, it's a chance for us to improve our system to keep things going right. So let's talk about what can go wrong. I've mentioned many times that one of the biggest pieces of my job is working with clients and talking with them when things do go wrong. So getting alerts from clients. So our clients put all of their data into their database and they might have failing results of their own standards, of their blanks, of their sample split repeats. They might have anomalies in their QC data, and this prompts an urgent investigation and corrective action. So if they're receiving results outside of the expected range, then we can go back and look and see what's happening there and help them to get that data that they need and make sure that their results are accurate. PTP failures. So these do happen. This, in any blind sample testing, it can indicate systemic issues in method accuracy or analyst techniques. So when we get a PTP failure, we're going to go through this one sort of as a case study, but it just, again, prompts us to do an investigation and some sort of corrective action. And based on what you're finding in your investigation, will determine how severe your corrective action needs to be. And when I say severe, I just mean how big. And then bias issues in standards. So as we saw in our QC charts, we can have shifts in recovery rates or consistent low or high results. And this can signal that we're having a bias in sample prep, instrumentation, or reagent lots. So something like this will signal us to start a root cause investigation into that. And like I said before, because our samples go into streams, we've already got our root cause investigation started because we know exactly where our starting point should be and where this sample has gone throughout the process. Outliers in QC charts. So our quality team tracks our QC charts, and if we're seeing data points outside those control limits, that hard limit, we need to know what's happening there and why that's happening. Or if we're seeing trending patterns, which we've already talked about, that'll trigger a more formal reporting process, as well as a method revision, but sometimes you're able to find it right away. So moving into a bit of a case study, when things go wrong, generally I encourage, even when it might not be the biggest thing that has gone wrong, I encourage our lab techs and scientists and prep staff, all of us, to put in an NCR. So I encourage them because then we have traceability. We know how often a problem is happening, and we can do statistical analysis on the issues we're seeing. So the purpose of the NCR procedure is to document and resolve deviations from expected standards, whether identified internally or by clients. So that's an important piece. I talk about this feedback loop, and when I'm talking about that, it's so important that you're seeing it externally and internally and using all of the data you're receiving. Our step-by-step process is the initiation. So a supervisor or designate completes an initial assessment of the situation, and in my case, they start a form, and that form gets sent to quality, and then quality sort of pulls in what they need to. But the NCR will be assigned to a section or BU quality personnel, depending what it is and who the subject matter expert will be, in order to figure out the root cause and then the best person to determine those corrective and preventative actions. There's a root cause analysis. Generally, this is conducted by a supervisor or assigned personnel, but oftentimes our quality team will pull together a team of people. If it's a big enough NCR and you think there could be a lot of changes around it, you want to pull in as many people as are needed to get to that root cause and make sure you're not missing it, especially if you're having repeat NCRs. So that's why it's super important to document them every time, no matter how small. If you're having a small error but several times, that's actually indicative of a big error. So it's important to encourage them to report them. And then moving to corrective and preventative actions, defining the actions, assigning the responsibilities, and setting target dates. And that is the most important piece in your NCR process, is the target dates. Not only setting them, but following up. So you have these great corrective and preventative actions. You've figured out what the impact of the error could be, and then you need to follow up and do an effectiveness check. So a supervisor will review all the actions and confirm the effectiveness. Without this piece, you're not going to make sure that you are mitigating this issue every time. Once you're sure that your measures have been effective enough that it's not going to happen again right away, you close the NCR. So let's look at a little bit of a case study. I talked about a PTP failure. So we've sent our analysis in, we get back the report, and we had a poor performance. What do we do? So the quality personnel will take the report. They'll start the NCR process by documenting the issue and sharing the information with relevant personnel. We'll do a root cause analysis. In this case, we would pull in all of the scientists that were part of the PTP, as well as extras, because you want to run it with more than one scientist to see how your performance is. And then the action in this case is to rerun all the groups that were run with the PTP and run the PTP in the same conditions as the initial run to determine the issue. So if you're able to then get the proper answer or the proper data range, then you can follow up, document what you believe has happened and the findings, and then there's closure to that. If you don't, you need to figure out what's gone wrong as well, and then follow up, and your corrective and preventative actions will change based on that. And then again, once you've determined that you've followed up enough and you have an effective solution, you'll close that NCR. Okay, continuous improvement. So there are several ways that we use different tools for continuous improvement. One of the most important is internal audit processes. And the purpose of an internal audit is to ensure ongoing compliance with ISO 17025, as well as your internal SOPs. And this is really important because not only are you checking yourself against your own standard operating procedures in an internal audit, you're also checking it against the standard, the ISO 17025. And this is driving continuous improvement across all lab operations. When do internal audits happen? Well, you should do them yearly, but also if you are seeing a lot of NCRs within a certain method, you'll want to do an internal audit to get to the bottom of that. So some key steps in the audit cycle: planning and scheduling. Audits should be scheduled annually or as needed, and then the scope and objectives are defined in advance. It's important when you're scheduling to think about how busy the lab is going to be. If you do an audit in a really busy period, people might rush through it and then you're missing things. So you need to think about when is the best time to audit a method so that you're getting the best feedback from your colleagues as you can. Audit execution. So making sure that you're using auditors that are trained internal auditors and they're independent of the audited process. So it's not the same person doing the process as auditing the process. It's someone only in charge of the audit. At SRC, we always get our internal auditors trained by Kayla. They have amazing training there, and it's all online, so it's great. But they're also, we do follow-up training and competency checks for our auditors through our quality department. And they are expected to do interviews, observations, and document review within the internal audit. Checklist and evidence collection. So we have a standardized checklist that's used to assess the conformance to ISO as well as our own SOPs. And then the observations are recorded and linked to ISO clauses. And then all of the auditors send those findings to me. I make an audit report. We go through it. We ensure the effectiveness of those before closure. And during the closing meeting, we review the findings. And as you go through a closing meeting, you might be able to bring up evidence that wasn't available right away or someone forgot about it. And then once they leave the conversation with the auditor, they remember, oh, they do that, and they can bring that to the closing meeting. And reporting and follow-up. As I said, once your audit report is issued with your corrective actions, you need to verify that the effectiveness of those actions is good before closing. And then the benefits of internal audits. So they reinforce adherence to your SOPs and your ISO standards. They identify gaps and areas for improvements. They support staff training and process transparency, and they enhance readiness for external audits. And a key thing for the supporting staff training is, although you might do competency training or competency checks throughout the year with your staff, sometimes people can actually find efficiencies in a process, and it's not that them deviating from that SOP is the problem. It's that they found an efficiency and your SOP should be changed because that's part of continuous improvement. So external audits are our other form of continuous improvement. And of course, in my case, auditors from SEC come and audit not only our QMS, but our technical methods as well. So we get two auditors. It's usually over 3 days. One of them sits with me for the whole 3 days. The other goes with our wonderful lab staff and goes through their technical methods with them. We do one formal on-site audit every 2 years to verify compliance with ISO 17025:2017, but also through SCC on the off year, you kind of do a virtual audit. So I'm sending them our PTP performance, and then sort of an overview of how our year has gone and our internal audits. The review that happens every 2 years is comprehensive, and it includes your PTP performance, your NCRs and corrective actions, your internal audit records, and your training and competency logs. So they go through every component of your quality management system, essentially, as well as any method validations that have changed. And when that starts, we start with a pre-audit questionnaire. So basically they send me a matrix that has every clause in the standard, and they say, okay, tell me how you are complying to these clauses. So I send them all of the SOPs, forms, laboratory information bulletins that go along with every single clause in the standard, so that when they come, they can do an in-depth inspection of the facility, procedure, and documentation while already having that background. And yeah, the SOP review, every standard operating procedure is examined for compliance, and then staff interviews. So the auditors engage with personnel to assess understanding and implementation of the standard. The outcome of external audits is identification of strength in areas for improvement. And really, these audits are very collaborative. They're not coming in and telling you what you're doing wrong. They're coming in and telling you how your lab can improve to follow best practices and the standard even better than you are. The issuance of findings and required corrective actions. So of course there will be findings. Then as a lab, once the auditors leave, you tell them how you're going to approach this in order to make sure that you're having an effective action with regard to the finding, and then verification and resolution and follow-up assessment. So basically, the next time someone comes to audit our lab, they will go back to what they looked at the first time, or the last time, I suppose, and you start there. So are those changes still in effect? Are they effective? Does anything else need to change? Okay, now we have all of our tools in place. We have an idea of what we're going to do when things go wrong and how we're going to get back on track with things going right. How are we going to get people to buy in? And this is the hardest part. People often view quality as an obstacle, but quality can be very additive. So what we want to do is change the culture around how people see it. So one of the things, as I said, is I encourage people to report nonconformities. We take these nonconformities with a very positive and efficient response. So people will continue reporting if the outcome makes their lives better. So if you are taking those nonconformities and you're using a solution that's going to find an efficiency and improve the lab, and you're fast and efficient with your responses, people will continue reporting. And suddenly you're getting all these nonconformities and you have an opportunity to know what's actually happening in the lab, because oftentimes as quality people, we're not right in the lab. So it's a really good feedback loop from an internal standpoint. Something that I do is quality tidbit seminars. That's what I call them, and I love them. I do every other month. I schedule one. I hit on a different topic every time from the standard. You just pull something out, pull out how it relates to what your lab is doing, and then it just keeps people engaged in quality. It keeps them thinking about it. Suddenly you have people coming to you and having ideas of how to improve things. So as long as you're consistent in the education on quality, I think you get a lot of buy-in from that. Preparation for audits. So when we have an external audit, our last audit, of course, you always do preparation with the people that are going to be audited, but we actually did it with the entire council this time. So at SRC, we have a corporate area that does the finance, the IT, the HR. They're incredible, and they know exactly what they need to provide as long as they're brought into the loop before your auditors get here. So bringing in all of those people can make a massive difference as to how your audit goes. Including quality in all meetings. So not just having these quality tidbit seminars, but also in your morning safety meetings. And I know sorting and separation and Geo especially do an emphasis on quality every meeting that they have and in their supervisor meetings. And then showing continuous improvement with the QMS. And this is huge too. If you want people to find ways to improve in their own areas, you also have to improve in yours. So as a quality supervisor, my job is to figure out how can our quality system be better, be easier to use, and follow the standard better so that everybody can use it. Okay, so that takes us to our key takeaways. So I hope that everybody has found some sort of value in what I've said today. I think the biggest things are hitting home the importance of quality, making sure that everyone understands quality ensures accuracy, reliability. It allows us to be accredited. Operational efficiencies, continuous improvements, and protection of environment and public health. Data integrity, that was a huge part of the talk. Maintaining that data integrity involves proficiency testing, standards, QC charts, blanks, sample split repeats, reagent blanks, internal and external audits. So those are all of our tools to make sure things are still going right, and our tools we use when things start to go wrong, things like handling issues. So when things go wrong, making sure you have a reliable process, like your nonconformity reporting, then the steps are followed to document, analyze, and resolve those deviations. And continuous improvement. So continuous improvement driven by internal and external audits that are going to help you identify your gaps, reinforce adherence to standards, and support staff training and process transparency. With that, I'll just touch on the soonest upcoming events. There are a lot, but right away here, Roxanne is actually going to Victoria. So if you are also going to the Canadian Ecotoxicity Workshop, she would love to talk to you about quality there. She'll be there October 5th to 8th. And then we have a few other conferences coming up, one in Saskatoon, Winnipeg, and then another geological one in Saskatoon. So you can find us there and in many other places, but those are the ones that are coming up right away. I'll open the floor for questions.
Great. Thank you very much, Danielle. And thank you, Roxanne, for joining. So I've got, just to note, if you'd like to ask a question, please on your control panel on the right, click on the question box and type it in there. So to begin, I've got a two-part question. How often do you run QQ blanks, and does your SRM material go through exactly the same process, including grinding, as the blanks?
Our CRMs usually come ground, so no, they don't. They're already prepared in that way, so that would be a different process, and we do ours in each group. Roxanne, do you have any variants there?
No, it's the same thing for us as well. They typically come dried and ground, and so we don't have to take them through that process. The method blanks, we take them right from the start all the way through the process. So if we are going to be grinding, we would have just like a blank sand, and we would take it all the way through the process.
Okay. How do you account for uncertainties in your methods?
So, well, that's a really, I could do a whole talk on that too. Maybe we should do another, but I will just say that when we're doing our initial method development with clients, or when I'm working with the lab supervisor to do our initial development, that's where we figure all of that out. We have a really strict process for that. That's going to track all of those uncertainties, all of those errors, and it gives you a starting point. That said, if you're seeing things change over time, you're going to have to go back to that method validation, and you should technically be doing method validation and verification over time to make sure that your uncertainties and errors are very robust. So when a client comes to you and is seeing something, you have something to go back on to show them exactly where that is coming from. Roxanne, did you want to add to that?
I agree with that as well. And when you're doing method validation is typically when you do that method uncertainty as well. However, it is best practice to go back to that, because then now you're going to have your historical data. So you're doing duplicates with each run, or every 10% of samples is a duplicate. And so now your method uncertainty is going to be a lot more robust as you go on in your process.
Okay, great, thank you. Question about NCRs. What software do you use to track your NCRs and actions? And also, do you rank your NCRs by risk to determine the level of response?
Yes, I love this question. I'm so excited that I get to talk about this. So actually, we just got a new, our software before was SharePoint, and that is wonderful, and it was great. But we have just gotten Master Control, which is an EQMS, and it's so good at tracking and traceability, and it's much more automated. So we do master control for NCRs. I think the other part was assess the risk. Yes, so every NCR that comes in, there's a risk associated with it or an impact, and we use a risk matrix. So it's basically the likelihood times the severity, which gives you your risk score, and then the priority of how those NCRs are resolved, or the priority that you would do a meeting about those to resolve them, would be based on that risk score and the impact it's going to have to your lab and the data that's coming. Because although the error has happened, you're still running samples, so you need to determine what's going to be affected by that. Roxanne, did you have anything for that?
Just to add that we are very excited about the EQMS, the master control, coming into play here, because what we did in the past was very manual. So this is going to add efficiencies and be able to track those NCRs so much easier. So we're very comfortable.
Well, your excitement is palpable. What is the most common cause of QC failure in your experience, whether it's material itself, human factor, instruments? And I guess this person is asking particularly about the gold fire assay process.
Oh, interesting question. We've seen several different causes. I mean, it comes from everywhere. Things are inevitably going to go wrong. Whether it's personnel errors, whether it's instrumentation, there are so many different sources that it can come from. And I mean, we've seen it all. And you just, as they come, you find that root cause and you figure out how to try to not let it happen again.
Yeah, I definitely agree with that. You don't really want to see that reoccurring error, right? Or the cause of that error. So once you kind of get to the root of that and can eliminate that, you're hopefully not going to see it again.
Okay. So someone asks, is it workable to use trend analysis to identify error from lab techs and techs deviation?
Oh, that's an interesting question. I don't know that we've done that specifically. Roxanne, have you done that?
Not really. The only thing I can think of would be your QC charts, right? Your QC charts and your blanks. And so you would be trending the data from that.
Yeah, and I get, you know what, actually, I suppose with regard to that, when we do PTP samples, we keep them in a library. And so when somebody is learning how to run samples on a specific method, we know that we have samples they can run and what the expected values of those are going to be. And so that's an easy way to do that without using the standards, where they also already know what they're expecting to get. So using those PTP samples that are so, they have really robust values tied to them, allows us to make sure that our techs are competent in those methods.
So someone asked, notes that data sets with more variability will have larger standard deviation, and therefore thresholds of 3 standard deviations will be larger. More consistent data sets will have smaller standard deviation values. So more noisy or inconsistent data will have fewer outliers. Does it not punish more consistent data?
Roxanne, do you want to start?
No. That is a great question.
Roxanne, would you
I don't know if you would say it's punishing more consistent data. If you have a method that's very consistent, that's what you want to see. So I don't think you would really be punishing it.
Mm-hmm.
Thank you. Do all certified labs have to be ISO certified? What are the minimum obligations for ensuring quality for certified labs?
So that is an interesting question. You don't have to be accredited. it's really good to be accredited. For SRC, we see a lot of value in being accredited, and that's why we do it. It's difficult to run a quality system if you're not getting that external feedback. Your internal quality system is great, but external feedback is so important to ensure that you're catching every part of it. Basically, at SRC, we get accredited for as many methods as is useful to industry and what emerging methods are coming. I think that's probably my best answer to that, because no, you don't have to be accredited, but it's a massive benefit to your quality system and the data integrity.
And I'm going to step in here as well. When you are doing drinking water analysis, you have to be ISO 17025 accredited. So that is a requirement of labs to do drinking water analysis. And the majority of the environmental analysis, your client requests that. I believe it is a requirement as well from like the environmental standpoint and the government. So you're going to want to be, if you are going to do any of that environmental or drinking water, you have to be.
Okay. So someone writes, as a client, I like the idea of sending duplicates. The question, though, is since analyses are charged per sample, will the duplicates be charged as well?
Yeah, because I can't know that they're duplicates.
Absolutely, they're blind duplicates.
To give you a deal, if I know it's a duplicate, that completely defeats the purpose of the duplicate. So I am going to make you pay for your duplicates.
Yes, and I agree. Yeah.
Someone asked, or wasn't sure if you had answered how many QQ blanks you run. Are these 1 in 5, 1 in 10? Could you elaborate on this a bit?
So for method blanks, Roxanne, what's your?
They're run per batch.
Yeah, we do every 20 samples or group.
Yeah, it does depend on the analysis. Like we have our method blanks that we'll run per batch, but then we also do our reagent blanks, and those might be ran every 20. They could be ran between high samples to clean out your instrument, that type of thing.
Yeah, there are different situations where it changes, and also if you have a small group, you're not going to skip that, so it goes per group as well.
Yeah.
Okay. Well, so we, I think, have time for maybe 1 or 2 more questions. Lots of questions coming in. Your control charts use CRM, certificate mean, and standard deviation for control limits. Some organizations, labs and clients, use the actual mean and standard deviation of the data to define control limits. The premise for doing this is that the original certificate data are not applicable to monitoring an individual lab. Any comments on the validity of this procedure?
Sure. So actually we use both. We have standards that we've actually created as well, and we do control charts on those. But in order to place a CRM into use, it is required that they follow the process of it's run on 2 different days, it's run by different analysts. The whole statistical analysis is done on the data that's received at our lab. So although we may use the actual CRM limits, we verify our own method regularly with those values.
Okay.
And I agree. Yeah, we do both as well.
Great. So thank you, everyone. Lots of great questions. We've run out of time, but these questions that were entered in the questions box will be forwarded to Danielle and Roxanne, and SRC will compile questions and answers to be sent out to registrants at a later date. So thank you to the both of you. That was great.
Thank you.
Thank you, Ryan. Thank you, Ryan, and thank you, Danielle and Roxanne, for that interesting presentation. We hope you enjoyed our webinar, and I'd like to thank all of our attendees and ask that you please fill out the short survey that pops up on your screen at the close of the webinar. A link to the video recording of this webinar will be emailed to you tomorrow. For more online presentations like this one, visit the CIM calendar of events on CIM.org. We look forward to seeing you at our next Solutions Exchange webinar. Thank you and have a good afternoon. Bye.